Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the pressure exerted by 1.0 mole of ethane behaving as a van der Waals gas when it is confined under the following conditions or the following condition, which is just 1,000 Kelvin in 100 centimeter cube. So the first thing we have to note is that we've been told that we're dealing with a van der Waals gas. And whenever you're dealing with a van der Waals gas, we're not going to use the perfect gas equation. So the first thing we have to do is to write out the parameters. We're told the number of moles is 1.0 mole. We were told that the temperature is 1000 Kelvin. We're told the volume is 100 centimeter cube. So we're told to determine value for pressure or the value for pressure. So the first thing you do is for you to remember that whenever you're dealing with a van der Waals gas and you're asked to determine pressure, there's just one formula that we use, which is pressure is equal to RT, so the gas constant, times temperature divided by the molar volume minus the parameter of the van der Waals, which is B, minus another parameter A divided by the molar volume squared. So A and B are parameters for the van der Waals gas that is unique to that particular or specific gas. So basically it's like a fingerprint, right? So that's just basically what I'm trying to say here. The first thing you notice is that we have the gas constant because the constant R. We have the value for temperature, 1000 Kelvin. We have the value for volume, not molar volume, but we can determine the value for molar volume, right? By just having volume divided by number of moles. So we have volume, we have number of moles. So basically we have molar volume, but we don't have the value for A and B. Well, this is great news because we're using the Atkins Physical Chemistry 11th edition textbook. At the back of the textbook, there's something called resource section. So hence we have the value for A and the value for B at the back of the textbook. So the value for A, the van der Waals parameter A is equal to 5.507 atmosphere dm raised to the power of 6 per mole squared, and then the value for B is just simply 6.51 times 10 to the power of negative 2 dm cube per mole. So yeah, that's it. Now we have A, thank God, and we also have B, or we have B and then we have A. Now I want to say something. The normal thing would be for us to substitute, but then we have an issue. We see that our units do not match for volume. We see for A, we have a dm raised to the power of 6, and then we have a dm cube. Hence, we have the unit decimeter for the values of A. But then in our volume, we have centimeter cube. We cannot proceed by substituting. We have to convert from either cm cube to dm cube or dm cube to cm cube. But what is better is for us to convert from cm cube, right, to dn cube. So that's basically how we're going to do it. So let's not forget that 10 centimeter gives 1 decimeter. So 10 centimeter cube would just be 10 times 10 times 10. So that would be 1000 centimeter times centimeter times centimeter, centimeter cube equals this 1 decimeter cube as well would just be 1 times 1 times 1. That's 1 decimeter times decimeter times decimeter, which is decimeter cubed. So we have that. Now we have the standard for conversion. Now let's go back to our question. We see that we have 100 centimeter cube. We have to go from 100 centimeter cube to decimeter cube. So we have 100 centimeter cube here, and let's just say we have x here. We would cross multiply to end up with 1000 centimeter cube x equals 1 decimeter cube times 100 centimeter cube. Divide both sides by 1000 centimeter cube. Divide both sides by 1000 centimeter cube. So you cancel out 1000 and centimeter cube and 1000 centimeter cube. So you end up with x is equal to, we cancel out the centimeter cube. We, of course, 100 here, 1, 1000 here, 10. So you end up with x equals 1 over 10 decimeter cube, which we can just say x is equal to 0.100 decimeter cube. So we have successfully determined the volume to be 0.100 decimeter cube. So now we have volume. Next thing we have to do is to determine molar volume. Like we've said, molar volume is just simply volume divided by number of moles. So volume will be 0.100 decimeter cube divided by the number of moles, which is 1.0 mole. So what we end up with is 0.100 decimeter cube per mole. So that's it. That is 100% it. Now, we've successfully done a lot. The next thing we have to do now is to substitute, because now we have the molar volume in the proper units. So to do that, just to make our work easier, let me just write out all of the parameters. We have the temperature is 1000 Kelvin. We have the A value to be 5.507 atmosphere. I'm only rewriting this honestly so I don't have to go back and forth up top, because it's going to be confusing to everyone watching if I have to like keep going up and down, up and down, up and down. It's going to be very annoying and confusing. So that's why I'm just rewriting this. So you have B is just 6.51 times 10 to the power of negative 2 dm cube per mole. So yeah, now we're going to substitute. P is equal to, we're going to substitute into this. P is equal to RT Vm minus B minus A Vm squared. So we start substituting. So pressure is equal to 0.08206, which is the gas constant, the unit ATM dm cube per mole Kelvin. Okay, times the temperature. We have our temperature to be 1000 Kelvin. All of that information divided by Vm minus B. So the molar volume, we know that to be 0.100 dm cube per mole, okay, minus B, which is just 6.51 times 10 to the power of negative 2 dm cube per mole. So yeah, that's the second one. Of course, to just break down our work, let's cancel out the Kelvin. So yeah, that's it. Let's not forget that we just put the first part. The second part is minus the value for A. We know that to be 5.507 atmosphere dm 6 per mole squared, okay, divided by Vm squared, which is just 0.100 dm cube per mole, all squared. Yep, that's it. So we're just going to simplify. So 0.08206 times 1000 Kelvin is just simply 82.06 dm cube atmosphere per mole, okay, minus, sorry, divided by, first of all, the denominator, which is just the addition of 0.100 minus 6.51 times 10 to the power of negative 2. So we're going to be focusing on the denominator. When you put this information, this subtraction in your calculator, you end up getting 0.0349 dm cube per mole. So minus 5.507 atmosphere dm raised to the power of 6 per mole squared, divided by 0.100 dm cube per mole all squared, which is just simply 0.0100 dm. Dm raised to the power of 3 squared is just dm6. Mole squared is just, or mole times mole is just mole squared. So of course we cancel out dm cube here, mole here, mole here. dm6 here, dm6 here, mole squared, mole squared. So pressure is equal to 82.06, its atmosphere, divided by 0.0349, which is just 2351.2894 atmosphere, minus this division here, which is 5.507 divided by 0.01, which is just 550.7. And then, of course, we still have atmosphere here, just like we did over here. We have atmosphere here. So I'm just going to put that down. So atmosphere. So we just do a simple subtraction in an input that in our calculator. So we have 1800.5894 atmosphere. And of course, you know, in chemistry, we can't just put this information and be like, yeah, this is our answer. We have to put in the lowest number of significant figures based on the raw values we're given in the question. So going back up top, we're given the number of moles, 2 sig figs. So then we have temperature, which is 4 sig figs, and volume 3 sig figs. So the lowest number is 2 sig figs. That means our final answer has to be in 2 sig figs. So that will be, it's going to stop here. So pressure is approximately 1.8 times 10 raised to the power of 2 atmosphere. Sorry, 1.8 times 10 raised to the power of 3 atmosphere. So that is the value for pressure of the van der Waals gas for ethane. If you have any questions, please do not hesitate to put in the comment section. That also goes for concerns as well as suggestions. I have done another question very similar to this on my channel, and the question is on the screen. So please do read it. And make sure you also click the description box, the link to the other video where a similar question but with different values have been done. Please go ahead and watch that video. If you like this video, please subscribe and like it. I also wanted to mention that for any of you who is struggling or is trying to improve or succeed in any of your STEM related courses, whether you're in middle school, high school, or college, make sure you email me at shahabitutoring@gmail.com. I help students be the best version of themselves in their academic career. I also help with mentoring services as well for students who are trying to navigate their career and academic life. So I've been told I'm a great tutor and mentor. So do not hesitate to email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.